Section 7.6, double and half angle formulas. So is there a formula for sine 2 alpha and cosine 2 alpha? The answer is yes. So 2 alpha means double, we're doubling the angle alpha. That's why we call double angle. So what we do is we are going to look at finding a formula for sine 2 alpha. The trick to do so is you can rewrite 2 alpha as alpha plus alpha. It's a nice trick. And based on the formulas from the sum of angles from previous sections, we had a formula for sine alpha plus beta. It was sine cosine, so sine the first angle, cosine the second angle, which are the same, plus cosine the first angle, sine the second angle. And notice that these two are the same, sine alpha cosine alpha or cosine alpha sine alpha. So then we can rewrite it as, if we combine them, as 2 sine alpha cosine alpha. That's the formula for the sine double angle formula for sine. For cosine, we can do the same thing. You can write cosine 2 alpha as cosine alpha plus alpha, and then find a formula the same way, cosine square minus sine square. Now, one thing important to see here, this cosine square, you can write it as 1 minus sine square. So we know that cosine square alpha is 1 minus sine square alpha. So we can replace the cosine square with 1 minus sine square, and that will give me the second line. Or from the first line, you can replace sine squared with 1 minus cosine square alpha. And that will give us 2 cosine square alpha minus 1. That's what we get. So these are formulas for sine and cosine. How do we apply them to an example? Let's look at this example here. They give us cosine alpha is negative 3/5. Alpha is in the second quadrant, pi over 2 to pi. Find the exact value of sine 2 alpha, cosine 2 alpha, and tan 2 alpha. To start with such a problem, we write the formula for sine 2 alpha as 2 sine alpha cosine alpha. Whatever they give me, like they give me alpha in the second quadrant, so I drew the unit circle and I labeled alpha there. And from cosine alpha, cosecant over, adjacent over the hypotenuse, and with the Pythagorean triples, it's a 3, 4, 5 right triangle. Now the sine alpha from the right triangle is the opposite over the hypotenuse, and it's positive. Cosine is given negative 3 over 5. Now all we have to do, multiply the top ones, we get negative 24 and the denominator 25. So sine 2 alpha is simply negative 24 over 25. We can do the same thing for cosine 2 alpha. So that was part A. Part B, which formula do I use? It has 3 formulas. Usually I recommend using the one that has whatever is given. So it has only cosine is given, so I would recommend using the last one. Just in case, because if you want to use the first one or second one, you need to know what sine is. What about if you got sine wrong? Then cosine 2 alpha would be wrong. So that's why I'm going to use the last one, which is the 2 cosine square alpha minus 1. Cosine alpha was given to us as negative 3/5. So negative 3 over 5 square minus 1. By order of operations, we first do the exponents, 9 over 25 minus 1. Multiply, you get 18 over 25 minus 1. Common denominator 25. Multiply top and bottom by 25. That gives us negative 7 over 25. That's cosine 2 alpha. The last one, they want us to find tan 2 alpha. But wait, we don't have a formula for that. So in this case, we do sine 2 alpha over cosine 2 alpha. Sine is given as, or we found it, negative 24 over 25. Negative 24 over 25. Negative 7 over 25. These cancel out. So the answer is negative 24 over negative 7. The negatives cancel. So that's for tangent. Now, after this, people ask, is there a formula for tan 2 alpha? Well, yes. Let me recall from tangent alpha over beta from in the previous section. We did say this is tangent alpha plus tangent beta divided by 1 minus tangent alpha tangent beta. So what we can do here, we can let alpha and beta, both of them to be at some other angle. Let's say theta. Then what we get, tangent, theta plus theta is 2 theta. So I'm looking for a formula for tangent, double angle formula for tangent. So this equals tangent theta, if you replace alpha with theta, and beta with theta over 1 minus tangent theta. So what do we get? We get tangent 2 theta is equal to tan theta, 2 tangent theta over 1 minus tangent squared theta. So this is the formula for the double angle formula for tangent 2 theta. And you can apply it to the previous example, see if you get the same answer or not, the 24 over 7. So find from the triangle, find what tangent theta is and substitute in here. And you'll see you get exactly the same answer. Now that's for double angle formulas. What about half angle formulas? So half angle formulas. What are the formulas for this? How do we find them or derive them? Well, I'm gonna take the cosine 2 alpha. From this one, I'm gonna derive everything. One of them was 2 cosine squared alpha minus 1 that we have earlier. So what I'm going to do here, I'm gonna solve for cosine squared alpha. So if you add 1 to both sides, we get this equals 2 cosine squared alpha. Divide by 2, 1 plus cosine 2 alpha all over 2 equals cosine squared alpha. Then what do we get from here? Cosine alpha. Cosine alpha is not just the square root. That's what a lot of students do. It's not. It's a plus or minus. So this, let's keep it for now. This is the formula for cosine alpha. But remember, I need alpha over 2. Within this line, these are the angles that I'm working with on this line, alpha and 2 alpha. We are allowed to divide or multiply the angles by any number we like. I'm going to divide by 2, each one of them. 2 alpha divided by 2 is alpha. So that gave me a formula for cosine alpha over 2. This is the formula for alpha over 2 cosine. It's cosine. That's half angle formula for cosine. Can we find one for sine? Yes, same way. Also, we can write back to the double angle formula for cosine. It's 1 minus 2 sine squared alpha. I need to solve for sine squared alpha first. So I'm going to add 2 sine squared alpha to both sides and then subtract cosine 2 alpha. Then divide by 2. So sine squared alpha is 1 minus cosine 2 alpha all over 2. Then sine alpha is plus or minus the square root of that. So we need to divide by 2 the alphas. So the angles, divide the angles by 2. So sine alpha over 2 is plus or minus the square root of 1 minus cosine. Dividing 2 alpha by 2 gives me alpha all over 2. So this is the half angle formula for sine. Now from cosine square, you know this formula here. Cosine square is 1 plus cosine over 2, and sine square here, 1 minus cosine over 2. If I divide them together, that gives me tangent square, which is sine square alpha over cosine square alpha. So tangent square alpha is, the sine square was 1 minus cosine alpha over 2. Right? See if we sine 2 alpha, cosine 2 alpha. And the cosine was 1 plus cosine 2 alpha over 2. Notice the 2 cancel 2 here. That gives me 1 minus cosine 2 alpha over 1 plus cosine 2 alpha. So that's a formula for cosine for tan squared alpha. If you want to find the half angle formula for that, all you have to do is divide the angles by 2. That gives me 1 minus cosine alpha over 1 plus cosine alpha. If you want to find tangent alpha by itself, so tan alpha over 2 is plus or minus the square root of 1 minus cosine alpha over 1 plus cosine alpha. This is just for now. But what we can do also, if you multiply, if we happen to multiply top inside this by, let's say, 1 plus cosine alpha. This is rationalizing, top and bottom. Watch what we're going to get. Tangent alpha over 2 is plus or minus the square root. On the top, it's 1 minus cosine times 1 plus cosine. That reminds me with a minus b, a plus b. A squared minus b squared. The denominator is 1 plus cosine alpha all square. So what do we get? Tangent alpha over 2. Notice the top is simply sine squared alpha. The bottom is 1 plus cosine alpha. It comes outside. If, of course, it's like plus or minus. That's why the plus or minus goes away here. So it's sine alpha over 1 plus cosine alpha. If you rationalize again for this, multiply top and bottom by sine alpha, let's say. So then that will give us two formulas for tan alpha over 2. One of them is sine alpha over 1 plus cosine alpha. And the other one is 1 minus cosine alpha over sine alpha. Those are good to know. Half angle formulas for tangent. Let's apply these formulas. How do we use them? So let's say we are asked to find the exact value. Find the exact value of cosine 22.5 degrees. If it's given in radians, this is about pi over 8 radians. Just convert to degrees to make it easier for you before you start working on it. So this, I don't know the decimals, and I can't do it in my head without calculator, right? So what we're going to do is we're going to do it using half angle formula. So if you think about this as alpha over 2, so alpha over 2 is 22.5. Multiplying both sides by 2, that gives me 45. See, now we know something about the angle 45. So cosine alpha over 2, what was the formula for cosine alpha over 2? Let's go back. This is sine, that's cosine. Plus or minus 1 plus cosine alpha over 2. So plus or minus the square root of 1 plus cosine alpha, which is 45 in this case, over 2. But I'm finding cosine 22.5 degrees. That's located in the first quadrant somewhere here. So that should be positive. So I don't need these plus or minus anymore here. Cosine 45, we should know it is square root of 2 over 2. All over 2. To simplify something like this is over 1 over 1. The LCD to all of them is 2. So we found the common denominator here, which is 2, and multiply the top of each fraction by 2. That's the easiest way to clean up the fractions. So what do we get here? We got the square root of 2 plus these cancel, square root of 2 all over 4. And this can be rewritten as the square root of the top over the square root of the bottom. And this turned out to be the square root of 2 plus square root of 2 all over 2. No need to simplify further than that. This is a good answer for this one. No need to use calculator at all. This would be really a good answer. Now the next one is, how about we need to find sine negative 15 degrees. So for such a problem, if you see negative sign there for small angles, we use odd-even identities, which says sine, to recall sine negative alpha is negative sine alpha from previous sections. So we can first rewrite it as negative sine 15 degrees. And then what we need to do here, we need to find that 15 is, if you take it as alpha over 2, is 15 degrees. So alpha is 30 degrees here. So we can use the half angle formula for sine. What does it say? Let me write it inside a bracket. It's a plus or minus the square root of 1 minus cosine alpha all over 2. So in this case, we do not need the plus or minus because angle 15 in the first quadrant, sine is positive. So it's 1 minus cosine. Alpha here is 30 degrees, as you could see on the right side, all divided by 2, and no need for the bracket here anymore. So then this gives us negative the square root of 1 minus square root of 3 over 2 all over 2. And again, as we did in the previous section, this is over 1 over 1. We can multiply the top of each by 2, like so. And then we get equals negative the square root of 2 minus square root of 3 all over 4. We can use the properties of square roots to rewrite this as the square root of the top over the square root of 4, which is 2. And that's what we get for negative sine 15 without using the calculator. Let's look at a different kind of example now. Let's say if sine alpha is given, so sine alpha is given as negative 5 over 13. Alpha is in the third quadrant from pi to 3 pi over 2. We need to find the exact value of say sine alpha over 2. So they give you sine alpha, they want you to find alpha over 2. The first thing we do is I want to know what's the formula for sine alpha over 2. That's the first thing. So first we write down the formula, sine alpha over 2. This is plus or minus the square root of 1 minus cosine alpha over 2. That's the formula for sine alpha over 2. So basically to get sine alpha over 2, we need to know cosine alpha. So I have sine, how do I get cosine? I always try to do triangle. Sine is the opposite over the hypotenuse, so this is 12. And now for the cosine, to get the cosine, let's see. Cosine is the adjacent over the hypotenuse, so 12 over 13 all over 2. 12 over 13 all over 2. So now we multiply top and bottom by the LCD, which is 13. So multiply by 13 by 13 by 13. So what do we get? We get 13 minus 12 over 26. And that gives us plus or minus the square root of 1 over 26. 1 over 26. So, but one thing we have to be careful about, is cosine just 12 over 13, like adjacent over the hypotenuse? We didn't pay attention to the angle alpha. What is alpha? Well, alpha was in the third quadrant. In the third quadrant, that's alpha. In the third quadrant, cosine should be negative. So this should have been should be negative. So that would be positive, and that would be 25 instead of 1. So that's a common mistake a lot of students don't pay attention to. Now, by the properties of radicals or square roots, we can rewrite it this way, plus or minus 5 over the square root of 26. Now, again, what about the sign here? Is it positive, negative, or should it stay plus or minus? Well, let's see. We know it's given that alpha between pi and 3 pi over 2 in the third quadrant. I want to know what I just found is sine alpha over 2. What is alpha over 2? Well, you can divide this inequality by 2. That would give me bounds on the alpha over 2. So that becomes 3 pi over 4. What is that then? That's in the second quadrant. So this means alpha over 2 in quadrant 2. In quadrant 2, this sine in quadrant 2 is positive. Sine is positive. So we say, finalize it as sine alpha over 2 is positive 5 over square root 26. And you may rationalize or just leave it like that. Both are fine. This is, usually I like to rationalize. This is how we found it. So the most important thing here, the first thing is to know the formula. Next is to pay attention where alpha is located and where alpha over 2 is located, because that makes a difference. If imagine like we didn't pay attention to alpha, then I would get 1 over the square root of 26. But the answer is 5 over the square root of 26. How can we apply it more or practice more on these things, double and half angle formulas? Let's look at it identity-wise. Let's say sine 4 theta, we're asked to prove that equal cosine theta times 4 sine theta minus 8 sine cube theta. We can start either on the left side or right side. I'm going to start on the left side. And I'm going to use the trick that I used earlier to prove the double angle formula. I'm going to write this as sine 2 alpha plus 2 alpha, 2 theta, 2 theta. So this equals, this looks like alpha plus beta. So it's sine cosine, so sine cosine plus cosine sine, cosine sine. But these two are the same. So that's basically 2 sine, 2 theta, cosine 2 theta. Or there's another way to approach this, just so you know. I'm going to write it here. Remember, we know the formula for sine 2 theta. It's 2 sine theta cosine theta. if you like to do it this way. Then I need 4 theta. How do I get 4 theta from 2 theta? I multiply the angles, all the angles I'm highlighting now, by 2, double them. So that gives me sine 4 theta is 2 sine 2 theta cosine 2 theta. So that's what I proved right now. So if you like to do it this way, which is faster, then that's fine. I want to keep an eye on the answer. What do I see? Inside the parentheses, I only see sines. So let's see, the sine 2 theta, it has a formula, 2 sine theta cosine theta. So let's keep it as is. And for cosine 2 theta, it has 3 formulas. Which one should I use? I'm not going to use the, I see the sine cube in here. So I'm going to use the one with the sines, 1 minus 2 sine square. 1 minus 2 sine square. So the 2 times 2 here is 4. 4. And keep an eye on what I need to prove. I need cosine outside, right? So let's keep cosine outside and distribute this sine inside. So that gives me sine theta minus 2 sine cube theta. Is it done? Well, I don't have 4 in the front, so I need to multiply this 4 inside. So cosine theta stays out. 4 sine theta minus 8 sine cube theta. And that takes care of it. So that's what I was looking to prove. So that was one about using double angle formula in identities. What about if half angle? Let's say cosecant squared alpha over 2 equals 2 over 1 minus cosine alpha. How are we going to prove this one? To do so, let's start with the left hand side. So I'm going to take the cosecant squared alpha over 2. And this is 1 over sine. 1 over sine alpha over 2. And we know a formula for sine alpha over 2. We proved it today. It's what? Plus or minus the square root of 1 minus cosine alpha over 2. The square cancels the plus or minus. It makes them plus and the square root. So that leaves us with this. This is over 1. If you multiply top and bottom by 2 like that, this cancels. So that gives me 2 over 1 minus cosine alpha. And that's what we were asked to prove. That's what we asked to prove. Let's look at another example. Let's say I want to prove natural log of the opposite value of cosine theta equals 1/2 natural log of 1 plus cosine 2 theta minus natural log of 2. We have absolute values. So it makes more sense to start on the right hand side because we get more options to work with. So let me rewrite that down. Natural log of opposite value 1 plus cosine 2 theta, absolute value minus natural log of 2. This equals to 1/2. Let's see. I need only one term here, not 1 plus or something minus. So I'm going to use the cosine 2 theta has 3 formulas. It's one of them is 1 minus 2 sine squared theta or 2 cosine squared theta minus 1. I'm going to use the second one, this one, because that one here with what I'm writing there is going to cancel out. See, the minus 1 and plus 1 cancel each other. And keep the natural log of 2 the same. This equals 1/2. Let's see what we have. Natural log of subtraction. I want to get these 2 natural logs to 1 natural log. Subtraction tells us to do division. So I'm going to divide that out. So the 2's cancel each other. And we can bring, keep cosine squared the same. The 1/2 up here. And the 2 cancels the 2. So that gives us natural log of absolute value of cosine theta. And that's what I was required to prove. What can be another application to this? Another application is how can we solve, because we learned how to solve trigonometric equations, solve the equation below on the interval 0 to 2 pi. Okay, 0 to 2 pi. What's the equation? Let's say cosine 2 alpha equals sine alpha. So how do we solve this? Now here what we can do, cosine 2 alpha has 3 formulas. One has cosine square and sine square, one has only sine square, and one only has cosine square. I'm going to choose the one with only sine square because the right hand side has sine in it. So this way I got an equation, quadratic equation, that has only sine in it. So if I move everything to the other side by adding 2 sine squared to both sides, keep this the same, and subtract 1 on both sides, then I can factor this one out. I can factor this one out as 2 sine alpha plus 1 minus 1. Check it out. 2 and minus 1, 1. Yes, that works. Now I'm going to set the first factor equal to 0 and the second factor equals to 0. So then we get sine alpha is 1/2 or sine alpha is -1. So 2 equations to solve. Remember, we're only from 0 to 2 pi. So what are the angles that only in the 0 to 2 pi their alpha is 1/2? We know it's 30 degrees is one of them, and 150 degrees is 5 pi over 6. These are the only two values. And for the other one, for the other case, or the other equation on the right side, there's only one value, which is 270. That's 3 pi over 2. So there's only 3 values for alpha that would satisfy the given equation. So again, it's really important to go back and try to prove the identities for half angle and double angle. It helps a lot in the practical equations or practical questions. If you just memorize it and then try to apply it straightforward, it's okay, but it would be better, as I said, if you know how to derive the equations, the formulas. The formula for double angle and for half angles. It makes it easier actually when you start working with the problems. If it's solving equations, proving identities, if it's simplifying expressions, if it's calculating values based on some other given value, those are important for this section. Another thing, keep in mind the given restrictions in alpha and which quadrant is given. Is sine positive, negative, cosine positive, negative, and the same thing for the other trig functions. And if alpha is given, where is alpha over 2, or vice versa? If alpha over 2 is given, in which quadrant, where is alpha located? So specifying in which interval each angle is located is important. This way you can test or know which ones are positive, which ones are negative.